Okay, here we go. 7-1, we're talking about interior and exterior angles. Specifically in triangles, but also we'll generalize to polynomials. So first of all, this is a first theorem of chapter 7, is referring to interior angles theorem in a triangle. So the sum of the interior angles in a triangle. These must equal 180 degrees. Bit of a mystery. Why 180? Where did that come from? Who invented this idea? Blah, 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 blah. Several ways we could prove this. I think the most effective one is looking at this diagram right here. So if you want to copy that down in your notes, we have a triangle ABC. We have angle 1, 2, and 3. And then we have a line that's drawn parallel through A to BC. So I'm going to mark those lines as parallel. And then I'm going to mark also two other angles. Let me get something a little bit smaller here. All right. 4 and 5. All right. Angle 1, angle 2, and angle 3, if you add those three angles up, I think most of would agree that they form a straight line. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 will equal 180 degrees. Yeah? Now, angle 1 you'll notice, and angle 4. Notice we have a transversal and we have two parallel lines. So I think most of you might remember from the previous chapter that those two angles have to be congruent. So angle 4 and angle 1 are the same measurement. By the same argument, angle 3 and angle 5 are also congruent. So we can replace the measure of angle 1 with measure of angle 4. We can replace measure of angle 3 with measure of angle 5. And now I can say, by substitution, those three angles must add up to 180 degrees too. So notice we started with an ordinary triangle and a parallel line, and we proved that the three angles must always add up to 180 degrees. All right. Reminder, what is the exterior angles of a polygon? There's an interior angle, yes? And there's an interior angle, and these are three interior angles. Exterior angles are out here. So there's an exterior angle, there's an exterior angle, there's an exterior angle. Now, here, here. So there's 6 of them in a triangle. Now, what about the far angle here? Well, most of you would agree that those are vertical angles. So this angle and this angle are vertical, so they're congruent. We don't call them exterior angles, though. All right. Now, we have a rule about these exterior angles. And the rule says, if you take one from each vertex, okay? So let's say I take this guy and this guy and this guy. Add them up. You'll always get a same sum. And so this gives us the exterior angle theorem. Yeah, exterior angle theorem. The measure of the exterior angles sum to 360 degrees, always. And it doesn't matter if you start with a triangle or if I start with a pentagon. All right, so again, I'm going to draw my exterior angles. So I extend at each vertex one side. And if I take this angle plus this angle, plus this angle, plus this angle, plus this angle, add them all up, I will get 360. I did it in class and I got 366. People were not impressed. Midpoint theorem. The segment joining the midpoints of two sides. So let's first of all, for the midpoint theorem, let's draw ourselves a diagram. So in your notes, copy this diagram down. I have segment AB, BC, and AC, and I've drawn the midpoints of each of them. I've labeled them F, G, and H. And notice we've marked them as midpoints. Okay? Now I'm going to join those lines. When I join those lines, that's called an auxiliary line. One of the three, it's called a mid-segment line. Now you should notice that I have three triangles that all go one direction, and I've got a fourth triangle goes the other direction, and those triangles eerily look like they might be congruent. Well, guess what? They are. We're not going to go through the proof right now, but I will tell you this, that the side FH is equal to either this and this, or this and this, or this and this. Can you tell FH is congruent to which one? In other words, should I put the 1, 3, or 2 markings on it? Yep, you guessed right. FH is the same as AG. Likewise, FG is the same as BH or HC. And finally, GH, whoops, just one, not two, is the same as AF. So, if I tell you BC is 17, then how long is it from F to G? Well, we clearly see now that I would have to take 17 and divide it by 2. 8.5. If I told you FH is 9, how long is AC? Oh, I got to double it this time. So we get 18. And now, if you remember, I now know which angle is bigger, A or B. Angle A and angle B are not the same. This is not an isosceles triangle. And I know which is bigger. Why? Because I know how to compare BC and AC. And I see AC is bigger, so this is opposite the larger angle. So angle B is bigger than angle A. All right. So the theorem says the segments that are joining the midpoints, yeah, those segments that we drew inside, they are, number one, half and parallel to the third segment. So again, FG is half of BC and it's parallel to BC. GH is half of AB and it's parallel. All right, that's it. Good luck in the homework.